Hi guys, girls. Okay, so it's that time of year. Yeah, it's Christmas coming, and I mean Christmas is great. I love Christmas, you know, and I think it's like one of these things that everybody should enjoy, regardless of what your faith or your religious beliefs are. Christmas is great. Yeah, I mean, come on. I mean, I'm a devout atheist. Yeah, I mean Christmas is definitely against my disbeliefs. Yeah. But that doesn't mean I don't know how to enjoy myself and have a good time. So I celebrate Christmas, I love it, yeah. And every year I put lights on the house and I stick them inside and I stick them outside, yeah. And then we put them away at the end of Christmas. I mean, in Spain it's even better. Christmas goes on till the 7th of January. We have Tres Reinos there, Three Kings, yeah, that's the big celebration, 6th of January, 7th of January. So you get even more time to use these things. And after you've used them, you put them away and you get them out next year, and what happens? Loads of them are not working, yeah. So, I mean, these things add up in price. You know, if you've got long chains like this, and if you use them outdoors, you've got lots of them, and lots of them are not working. That's lots of money to replace them, yeah. So you think these are simple. These simple things, yeah. There's loads of LEDs on bits of wire, yeah. I mean, this one, you've got blue and white, yeah, you can see, and a lot not lighting up at all, yeah. So you think we've got blue and white LEDs, so I must have like one wire sending the power to the blue and another wire sending the power to the white, and then another wire like the negative, the return, yeah? And then you think to yourself, well, actually, why are there 5 wires in here? Why does it need 5 wires going down here to do that? Okay, so what we're going to do today is we're going to unravel the mystery of repairing Christmas lights, yeah? How they work, how they're connected. And we're going to start off first with the little controller unit. Just want to talk briefly about that, and then we'll talk about what equipment you need to efficiently and effectively test and repair these, and then we'll look at fixing a few of the strings on this one, yeah. Okay, so right, no more ado, let's begin. Okay, so this is a little controller unit. Yeah, it's got an English plug on, so I brought a lot of these over from the UK with me, because they're even more expensive here than they're on the UK. For lots of them, yeah. I'm not going to bother to open this up because I know exactly what's in it. I'm going to tell you what's in it, yeah. Normally these things have 2 channels, yeah, whether they're 2 colour or single colour. Some more deluxe versions, yeah, have 4 channels, and you'll have 5 wires coming out of here, but this is a simple 2 channel one, and there's 3 wires coming out. It's exactly what you'd expect. One for the blue, one for the white, and one for ground, yeah. But let me just explain to you what's inside here. They are repairable to a point, yeah. But basically, I'm just going to draw a little circuit. I'll show you what actually lives inside this box, yeah. Okay, so this is the little control box, yeah. And this is the brains of the thing, yeah. If you look at these, you'll see that almost always they're 24 volt. This is worn off, yeah. But they're always 24 volts. And they're very, very often 24 volts AC, not DC, yeah? And you might wonder why does LED strings, which work off DC, require an AC power supply? And the basic reason for that is cost, yeah? Now, some of the more modern ones have like a switch mode type thing in here, but a lot of them, the older type, have like a linear, just a transformer, yeah? So I'm going to show you basically how the linear one works, and the switch mode one works pretty much the same way, yeah? So with a linear one, what you have coming in is your AC mains, yeah? So we'll have 240 volts, that's what we have here, yeah? Coming out of this transformer is 24 volts AC, yeah? AC, okay. Inside that unit, as well as a transformer, you will find then normally a bridge rectifier, yeah? Little bridge rectifier. AC. I won't bother to draw the symbol with the 4 diodes. I can't be bothered. It's Sunday, yeah? It's Sunday today. So coming out of here, effectively, you have pulsed DC. So what happens is, the bridge rectifier, you imagine your AC signals like this going positive and negative, yeah? Okay? What the bridge rectifier does, this end is positive, and it inverts the negative halves of the waveform. So you end up with this. All positive but pulsed, yeah? And whereas this was at 50 hertz, 50 times a second, or 60 hertz in the USA, this is 100 hertz, yeah, or 120 in the USA. And effectively, the reason you do that is to stop flicker, yeah. It isn't strictly necessary, but it stops flicker. Okay. Coming off here now, you will have some sort of circuit, usually probably a resistor and capacitor, maybe with a diode in it as well, something like resistor, diode, capacitor, yeah. Go into ground, yeah. And off here, this is your controller, yeah. Microcontroller, yeah. This is what generates all the sequences of flashing, yeah. Negative going to there. And then coming off here, you've got two outputs, yeah. We'll call them white and blue, because that's the colour of my lights, yeah. Now, this doesn't switch transistors or MOSFETs. They use something called thyristors, yeah. And the thyristor, so controlled rectifier, is a device, it's a 3-pin device like this, yeah. It has an anode, a cathode and a gate, effectively, yeah, or a control pin, yeah. And when you put a voltage, a pulse on here, it turns on, yeah. But the point of a silicon controlled rectifier or thyristor is once you turn it on and current starts flowing, it won't turn off again until the current stops flowing. So once you switch this on, it stays switched on, it latches on, and as long as current's flowing, it'll stay switched on, yeah. That's what that is. That's the difference between that and like a MOSFET, yeah. With a MOSFET, you turn it on or off, the same as a transistor. Right, so what they do is now, and this is why the AC will come clear to you. You have two of these, yeah. So here's one. Get into ground, yeah. And here's the other one, yeah. Get into ground. And from the top of these, this is where all your LEDs are. So you have a chain of LEDs, yeah. Normally there's 10 in a chain, yeah. And the same here, this is your other colour LEDs, yeah. Okay. And these come back to here. Your AC, your pulsed. Have you figured out why it's pulsed now? The controller sends a pulse to this to turn it on, yeah. And imagine, this is your half cycle of coming in, yeah. If it turns it on at this point where it comes to 0, yeah, this will start to conduct. It will stay conducting all the way through the cycle until it stops flowing. When it stops flowing, it will turn off, yeah. So if you turn it on here, and again you'll turn it on here for the next pulse and so on, so 100 times a second you'll turn it on. You have to just turn it on and it'll stay on until it drops back to 0. Now imagine what happened if you turned it on here. Yeah? Here. Now, it's only on for this period of time. Half the time. That's how you get the pulse width modulation, like half brightness, yeah? And by altering the point at which you send the turn on pulse, you can alter how much of that cycle it's on for and the brightness. It's a kind of pulse width modulation, but it's much cheaper to implement. Well, say much, a few pence probably cheaper to implement than your normal like microcontroller with a fast, you know, megahertz clock frequency and pulse width modulation. Yeah, it's just cheaper, and that's why they do it that way. Obviously, you get 4-channel ones as well. Yeah, but that's what's going on inside your controller. Yeah, so the wires you see coming out of it basically is just for the LEDs, yeah, and the ground. That's what you see, yeah. Okay, so that's basically what we have. Right, so that's explain what's inside the controller. Just mention this thing is quite often not a chip on the circuit board. It's quite often like encapsulated, like some sort of dye made onto the board itself and covered with like a blob of like black epoxy type stuff that you can't get off. So generally you can't replace that, and if you did, you'd have to program it. But there's no reason why you couldn't, if you really wanted to connect something like an Arduino or something to these sort of things, use MOSFETs and start doing clever things with them, if that's your thing, yeah, if you're into that sort of stuff. Anyway, that's what's going on in the controller. These you can change. Okay, so that's basically what's going on in there. Now, why does it have 5 wires? Okay, well that comes down to how the LEDs are connected up. By the way, I'll just mention in case it's confusing. the 3 wires that come out on the wire are this one, if you like, 24 volts. It's not ground, it's a 24 volts. Yeah, and then the 2 tops of the 2 LED chains. That's the 3 wires you see coming out. Yeah, that's what you see. Okay, in actual fact, because the LEDs, if you effectively, I'll confuse you again. The LEDs are outside, yeah, of it. So what you actually see is this connection coming out, this connection coming out, and this connection coming out. Yeah, that's what you actually see. The 3 wires. Yeah, we'll call it blue, white, and we can call it ground, but it's actually plus 24 volts. Yeah, that's what actually comes out on the wires. Now let's have a look how these LED strings are attached and how they're wired. Right, fresh bit of paper. So we know now, coming out of the controller, we got the top ends of the thyristors and the 24 volts. Yeah, so the way this is actually wired up is this. You've got plus 24, yeah, going to a string of LEDs. Yeah, I'll just draw a few of them. Yeah, times 10. Yeah, and then this goes back to one of the output of the thyristors. Yeah, call it the blue. Yeah, and then you've got your next chain of 10 LEDs. Yeah, times 10, yeah, going to here. Yeah, normally it's not quite like that. Normally somewhere in this chain will be a resistor. Yeah, in fact always, let's say the way, in this chain somewhere will be a resistor. Yeah, just to limit the current. And it's not normally at one end or the other. It's normally somewhere in the chain. Yeah, it doesn't matter where it is. It's somewhere in the chain. Yeah, there's a resistor, and they're generally something like about 100 ohms. They could be a bit less. You can, when you find one, you can measure one. Yeah, but there's a resistor in here somewhere. Yeah, and that's how it's wired up. Now you also have here your white. Yeah, and this is your alternate sets of LEDs. Okay, somewhere's the resistor. This one goes down to here, yeah, times 10, and so on. Yeah, so it just alternates. Somewhere a resistor, times 10, yeah, and so on. Yeah, blue, white, blue, white. Yeah, like that. So that's how it's wired up, and you can see you only need 3 wires to do that. Yeah, and that's perfectly fine. Apart from the fact our LEDs are not like in a vertical string, they're in a long chain that way, and this is where the other 2 wires come in. So to make this long chain, what you need to do is this. So this is the same thing, but this is how it actually is. Yeah, you've got your 24 volts and your blue and white, the 3 wires coming in. Yeah, till you reach the first LED. Yeah, then from here your 24 volt goes to the start of the 2 strings. Yeah, I've only drawn 3 LEDs in the string, but there's 10. Yeah, on each of these. Yeah, so it goes to the first one. I've drawn the resistors here, but normally the resistor is somewhere else in the chain. Yeah, the other end of the chain, one goes to blue and one goes to white. So by effectively grounding either of these via the thyristor, you can turn them on. Yeah, now you need 24 volts to go down to the next chain as well. So you've now got 1 wire for each string of LED. 1, 2, 3 is the 24 volts going down to the next chain. Yeah, and 4 and 5 are the return from this end. Yeah, and then same for the next chain. So 24 volt comes in into the 2 chains via resistors. Yeah, both ends of these again connecting to the blue and white. That's 1, 2 chains, 1, 2 returns, and the 24 volts to the next chain. And that's why there's 5 wires. Yeah, that's exactly why there's 5 wires all twisted together. So I'm sure you can see that now. Yeah, the reason this resistor isn't normally here is this. If we just show you on an actual LED, I'll just zoom down. Yeah, so you can see here, this is where, like, effectively like you return wires strap on. Yeah, this is where for me you get the 5 wires. Yeah, and you'll see that on these ones at the start of this chain there's a lot of wires, and if we follow it down after 10, so there's 10 of each colour. Yeah, so we'll go 1, 2, 3, 4, 5, 6. I'm still in the same colour as every other one. 7, 8, 9, 10. Yeah. So after this one, this is where you then you come to the next group of wires. Yeah. So you got 10 in each chain, and this is again why you start here with multiple wires, which is the start of the next chain. So you see these, effectively seeing these junctions I was talking about. Yeah. Because where there's one of these junctions, there's lots of wires already going into the LED. Yeah. This is not the place to put the resistor. So the resistor will be on one of the other ones tucked up inside here. Yeah. And it's just physically easier to do it that way. Electrically there's no difference, it's just physically easier to put the resistor there. Yeah. Okay, so that's how we've got them wired up. So all we need now is a method of testing all these chains of LEDs. The two most common things, in fact no, the most common thing that goes wrong with these is basically corrosion inside these. Yeah, corrosion inside this stuff. Second one is faulty LEDs, but much more often it's because the leg is rotted off. Yeah, sometimes if you're lucky, if you actually look down into the top of the LED, you can sometimes effectively see by the colour, the discoloration, which one's got a rotted off leg. Not always. Yeah. The other thing is where there's multiple wires going into the LED, it's much easier for moisture to get in here. So where the multiple wires join is the most likely place for the corrosion to be as well. Yeah. So that's just a couple tips. Anyway, let's have a look now at how we're actually going to test our LEDs. So to test the LEDs, one thing I'll tell you straight away, stripping this stuff off to test each one is not the way to do it. Yeah. A, because it takes a long time. B, because you're likely to make matters even worse inside here if you don't need to take it off. And C, you've got to put something back on. Yeah. The way to do it is to use sharp needle probes like these that you can actually stick directly into the wires. Yeah. So either side of an LED, two wires on an LED. Yeah, you can actually stick your probes in. Now, you may find that if you put your meter on diode mode, yeah, and stick them in, depending on the colour of LED and depending on your multimeter, you may get it to light up dimly. Yeah, and you'll be able to actually test them this way. So let's try it. So let's have a poke the wires in, try and make a connection. I'm just stick them in as hard as I can. I'm not getting anything there. Yeah, let's just turn it the other way around. I mean, I don't know if this is a good LED either, to be honest. Let's go that way. Yeah, can you see it's lit up? Yeah. So you can actually go along if you like, if your multimeter will light them up and do it that way. But that's not really the best way of doing it. The best way of doing it is to test all the string in one go. So you can start off with the first LED, so get the first one to lit, then go say to LED number 5 and then number 10 and do them in a chain, yeah, so many at a time. Figure out like, oh well, it's faulty somewhere between 5 and 10 and then narrow it down. Yeah, it saves a lot of time. And now you might think the way to do that is to use a bench power supply and set it to like 10 milliamps or something like that. Yeah, and that'll do. Yeah, so you would think. But you could use a power supply with a resistor, but the thing with that is the further down the chain you get, the dimmer they become, because the current will vary depending on how many LEDs you've got in the series. Yeah, and also you can get a situation sometimes with these where they'll light up with a test meter like this, but they'll only light up dim when they've got the full power, causing the entire chain to be dim. Or I've even seen them flash up, flickering very rapidly when there's power on them, even though they will light up with one of these. Yeah, so you really want to test them under a kind of a load that you would normally do so. Yeah, and the first way you think of that is let's use the bench power supply, set the current limit down to like 10 milliamps or something, and let's use that. Unfortunately, that doesn't work quite the way you might think it does. Let me show you why. So here's my bench power supply, yeah, set to 24 volts, yeah, and I've got a variable current limit like you do have with the power supply. So I can just stick my leads in here, yeah, my sharp leads. I'm not sure what the current's set to. Okay, I'll now short the leads, yeah, and that's now drawing 710 milliamps, yeah. Now an LED wants about between like 10's enough, yeah, and we can turn this power supply down until we get like around that. It's got a fine adjust. Yeah, that's about 10 milliamps, yeah, 20, 10, somewhere in the region, yeah. So it's in constant current mode, and every time I short it together, it'll draw that. What happens when we stick an LED on it? What do you think? Well, you would think that the LED just lights up at 10 milliamps, don't you? This is what actually happens. See the spark? And it's gone to 0, yeah? 10, 0. This LED is now open circuit, yeah? And the reason being, and that spark, is because my power supply cannot react anywhere near fast enough to stop that LED blowing. And the same's true with my other bench power supply, the one behind it. That one, you know, that big one, dual bench power supply, exactly the same. So that, I'm afraid, isn't going to get you out of trouble. But there's a very simple way to do it, yeah? Let me show you what that is. So this is an LM317. It's actually a KA317. It's a compatible Fairchild, I think that is, or Ferrand. I think it's Fairchild, yeah. So quite often these come as LM317, and it's a positive voltage regulator, yeah. And this thing is a very common component. It costs almost nothing anyway. And you'll probably find easy to find salvage ones off these, off old equipment, yeah. You can even find surface mount ones. And this little chip here can be used either as a constant voltage or a constant current supply, yeah. And the way to use a constant current supply is very simple. You just solder a resistor between pin 1 and pin 2, yeah. Simple as that, pin 1 and pin 2. And the value of the resistor will set the current that this actually supplies, yeah. This one, I've used a 100 ohm resistor, as you can see. And this is ideal for testing LEDs. So this is set to deliver about 13 milliamps, yeah. And to use this, all we do is, the orange wire goes to the positive of your bench power supply. So first of all, let's just connect that to the bench supply. So positive of the bench power supply, yeah, you see it's in there, goes to the orange wire, yeah. Orange wire. That's your voltage coming in. This is good for any supply up to 40 volts, yeah, and it'll still give 10 milliamps no matter what your supply voltage. But you also, by the way, if you don't have a bench power supply, 3 9-volt batteries, yeah, connect them in series. This is very easy to do because you just effectively just clip them together like this, yeah. You've now got between the positive and negative, yeah, you've got a 27 volt supply. Probably about 28 volts when these are full charge. No, yeah, maybe 28 and a half because obviously you hold a bit more than 9 each, yeah. And you can use this to connect to the LM317, exactly the same, couple of crocodile clips, yeah. So you don't even need a bench power supply for this. 3 batteries, just as good, yeah. So anyway, I've connected the bench power supply positive to here, yeah. I then want to connect the output from this, and the output comes from the other end, yeah. The only reason I use the orange wire is if I click the clip on here, it might short. If it shorts, I'll start blowing up LEDs, yeah. So that's crocodile clip on the output, and that then goes to my red test lead, yeah. 1 red test lead, positive, yeah. Okay. And then the negative meter lead we plug straight into the bench power supply. If I just find where I put my test lead, one moment. Okay, I now have it here, so that can go into here. So negative lead straight to the power supply, positive to the LM317, output of that to the red lead. That's it, yeah. And I've now got my 2 test leads, yeah. And what we can do is now we can switch on the bench power supply, yeah. Set to 24 volts. Right, now let's try an LED. Let's see what happens now, yeah. So red's a positive, I think that's the positive, yeah. And the LED now lights up. No more sparks, no more blowing LEDs, yeah. So we're now ready with our two leads to start testing LEDs, okay. Let's give it a go. So here's our LED string, yeah. So we'll switch it on, and we can see straight away on this first set of 10 that only the wires are working. In fact, it goes. We can check. You can see how many there are. So this is white working, and then we get to the first blue. Yeah. So blues start working here. So we can see that we got a set out, and if we check, there should be 10. Yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So exactly 10. I normally find it's better on the controller to set it so it's constantly on. Normally I have an option for constantly on, although sometimes it's on fading. You have to just figure out which is constantly on, yeah. But I normally find that constantly on is the best to work on this. Otherwise you might get a dose of epilepsy or something. That's still on fade. There is a constantly on option, just have to find it, yeah. So the first set of blues are not working, the first set of whites are. So let's just test our tester on the white ones, because you know we're working. And now let's have a look at the blue ones, yeah. So switch the lights off. And let's connect our bench power supply back up again. I only have one power lead at the moment. Okay, so you can see the first white one, there's 2 wires coming in and 3 wires going out, yeah. And we're not sure exactly which is the right wires, but it's quite easy to work out. So this is the first white one, so it goes blue, white, blue, white. This is the second white one, yeah. So we can follow the second white one back. We know where it is, yeah. We know that is the output from the first LED, yeah. Usually, I found them now, it's the black lead is the one coming in, but you just have to try polarity until it works, yeah. So we can see on the second LED where it goes to, yeah. It goes to here. So this is the first one, yeah. Let's make sure we've got a connection, and then one of these two must be the input. So let's just have a little stab, nothing there. So you can use sewing needles for this, by the way, as well. They're just as good, yeah. Perhaps even better with a sewing needle, yeah. Should have it somewhere here. One of these is definitely the right one. Yeah, it's there. Got it. You probably saw it. Yeah, you saw it there. You saw it flash. Yeah. So we've got a connection on the first one. So we know where it comes in. So what we can do is now we can count further down. So 1, 2, 3, 4, 5. Yeah. So you go to the 5th one. Yeah. And again, we'll check the output from that one. And this is how you would do them. So you can go all the way down the chain. We know this chain's working anyway, but it's just to prove that the tester works. Yeah. So with that one, I'll come back into the input. Wire stabbed in again. And if we get a connection, I should get all these to light up. Yeah. Just go with the right one. Just make sure. 1, 2, 3, 4, 5. I was on the blue one. You have to be careful. You have to make sure you're actually on the right one. Yeah. Output of this one. There. Input to this one here, and again we should be able to get all, yeah, there, yeah, all lit up, yeah. And then you can just sort of work on down the chain. We know those 5 are okay, so if you like we can carry on from here and we can go to the end of the chain, but we know that they're all okay, yeah. So in 2 goes we can test that. We know that set of okay. Let's have a look at the blue ones, because we know the white ones are working, yeah. Blue one's quite obvious, so coming in here, 1 wire, yeah. Which wire is the one going out? Well, it's quite easy. It's the one that goes to the next blue LED. There, yeah. So, in fact, we can stab it down here for that matter. So, 1 there, yeah, and 1 here. That might be the faulty one. We know we've got a faulty one, and quite often the one where there's more than 1 wire is where the problem actually is, yeah. So let's go from here. This is the second one. Let's go to the 4th one, which is here, yeah. And let's see if we can get these to light up. So I'm on the output of the fourth one, so these should both come on together if I get it right. Yeah, let's just have a look. Yeah, they're both on, yeah, so we know they're okay. That's 1, 2, 3, 4, 5. I'm down to 5 now, yeah, this is every other one, yeah. Okay. So we know the first so many of these actually work, yeah. I could carry on down the chain for the rest of those blues, but we've already found this one at the end doesn't light up, yeah. Doesn't want to work. I'll just test it again to be sure. So we can come from here and we can go to this one, yeah. And it doesn't light up. And as I said, the ones where there's multiple wires is commonly where the problem is. So well, let's have a look at this one. Let's this is where we now have to start stripping off this plasticky stuff, yeah, which is can be quite tricky to get off actually. And often you'll find that one of the legs is actually just completely rotted off the LED, or sometimes it's a faulty LED. Yeah, I mean it's possible. You probably want to sort of sharper knife than I have for doing this. You can see now why you don't want to be doing this on every single one to test them, yeah, because it's fiddly and it's a bit time consuming. You've got to put something back on when you're finished. I normally just use insulation tape, green insulation tape, when I've done. And we don't have very much rain here anyway. I did the same in the UK, it's just that every year I'd have to fix a few more and I'd have to fix some of the ones that are already fixed, yeah. So let's have what's inside here. Let's see if the resistor's here. I don't think it will be here, by the way. So there's normally like a white plasticky thing down the middle. There you go. And then this horrible green hard stuff on the outside of it. Still doesn't want to come off. Probably doesn't help because these have been used outside for a considerable period of time, yeah, as well. So that's probably another good reason why these don't work. Get the rest of this stuff off here. So I'm down to the actual terminals of the LED now, yeah. You can see the corrosion in here. Can you see it? Let me zoom down on it. This is very commonly what you find, yeah, in here. So one leg looks quite rotted, although it's still attached to the LED, I think, just about. Let's bit this green off. Let's have a look. Yeah, these actually seem to be. It seems to be attached, but it's probably gone there. You know where it goes inside it. It's probably gone. So this one we're going to replace this LED, yeah. And we're just going to stick another one in. If you make a note, you can see inside it. I can see like there's like a big like a hoof there, yeah. So you know which way round the replacement goes. One wire coming out, 2 wires going in effectively, yeah. As per my diagram. So let's get another LED and let's stick the LED on here. So this is the replacement one. You can see which way round it goes, yeah. We can use our little tester as well just to test the LED. Yeah, let's just check it. Other way around it is, in fact. Yeah. So we know it's good. Solder it in. Job should hopefully be done on this chain. If not, we'll have to go further down the chain. So there's our LED soldered in, yeah. So let's just try it now. I have to just swap my power lid over. I have got another one somewhere, just couldn't lay my hands on it. Okay. Plug these in and let's see if this actually lights up now, yeah. See if this one actually wants to come on. Yeah, it does. So you can now see if I zoom out that the first set now I have both the red and blue, the white and blues working, yeah. And I can just work away on the chain now, just keep going down until I eventually find another, yeah. So one starting from here, yeah. And this is the next set that aren't working. So this is where we carry on from, yeah. And again, you will see it's one that has 1 wire coming in and 2 wire going out, yeah. As I showed you, that's actually part of the next sequence, yeah. 1 in, 2 out. Okay, so I hope that's unravelled the mystery. You can see by doing it this way, you can test them fairly quickly. You know, chain after chain is not so difficult. And even for, this is like a 240 LED set, it won't take you anywhere near as long as you might think to actually fix this, yeah? Okay guys, hope you enjoyed that. Have yourself a very Merry Christmas, although I'll see you many times before then if you subscribe to the channel. Lots of fun on here. If it's your first visit, come and join us. We do all sorts of interesting things, and I'll see you all soon on another one, guys. Feliz Navidad, and ciao for now.